Hey guys, in this video we are talking about how to use Avogadro's number. So Avogadro found that in any 1 mole of any substance there's 6.02 times 10 to the exponent of 23 particles. So we use Avogadro's number to do conversions from moles into the number of particles, or if we're given the number of particles, to figure out the number of moles we have of a substance. So let's do moles to particles first. So let's say that we had 100 moles of water, H2O. We would take that 100 moles and multiply by Avogadro's number. Now we need to talk about the units of Avogadro's number. That is, you can think of it as number of particles per mole, but most particles are made up of molecules. So I'll go m/c per mole for our units. So I have my 100 moles of water. I need to multiply with something with moles on the bottom so that moles will cancel out, and something with number of particles on the top. Well, molecules are particles, so I can use Avogadro's number. So I'll go times 6.02 times 10 to the 23 molecules per mole. So I would suggest that you do Avogadro's number on your calculator first. Go 6.02 times 10 to the exponent of 23 equals, so my calculator's got it there in scientific notation, times 100 would equal 6.02 times 10 to the power of 25 molecules. So that's all there is to changing something from moles to molecules. Let's do one where we go the other way. We still use Avogadro's number for doing sort of the reverse, taking the number of particles and converting it to moles. So we have CaCl2, and we have 3.550 times 10 to the 19 molecules of that, and we want to know how many moles we have. So we'll take our number in molecules and we'll times it by something that has molecules on the bottom over mole on the top, so that molecules will cancel out and we'll get our answer in terms of moles. Well, that would be Avogadro's number just flipped upside down. The 6.02 times 10 to the 23, that's attached to the unit of molecules. So we'll put that on the bottom with molecules, and that's per 1 mole. So to do that in your calculator, to avoid making a mistake, I would suggest you use some brackets. So I'm going to go open bracket 3.550 times 10 to the exponent of 19, close bracket, times 1 over 6.02 times 10 to the power 23 is the same as divide by 6.02 times 10 to the power of 23. So I'm going to do it as divide. Open bracket 6.02 times 10 to the 23rd equals, okay, so I've got to switch hands, so that's what I got. 0.00, how many zeros? 1, 2, 3, 4, 5, 8, 9, 7 mole. Let's think about our significant figures. In the question we had 1, 2, 3, 4 that were significant, so we want to have 4 in our answer. 1, 2, 3, 4, and I'm just going to put that into scientific notation. So that would be 5.897 times 10 to the power of, how many times did I have to move the decimal? 1, 2, 3, 4, 5. And because this number was way less than 1, it's closer to being 0, so it's a negative exponent. 5.897 times 10 to the negative 5. And so I hope this was helpful. If you have any questions, let me know. Bye.